All right, howdy. So let's look at forces on charged objects. So we'll have some sort of charged object, let's say here, and it will have some charge. So we'll give it some charges in there. And right now we're going to be agnostic about what's doing this. Next time, then in the next lecture, in lecture 3, we'll find out exactly what's doing it. But right now, let's just look at this guy here and say, okay, we're going to put this charged object out in the world, all right? And then we'll see what happens. We'll see that sometimes that if you take the charged object and compare it to an uncharged object like this guy, there'll be some places where the charged object will feel a force, F, right? And the uncharged object will not. And in fact, we can have a third object here that's negatively charged. And if this negatively charged object is put in there, it's going to feel a force down this way, in the opposite direction. All right, so we've got 3 kinds of objects: positive, negative, and neutral, right? And in this region of space, 3 things can happen. It can be pulled down, it can be pulled up, or nothing at all can happen to it. So there's some property of the environment that does this. So out in the world, there's something out there that's affecting these 3 different kinds of objects in different ways. So there's some effect in the world, in the environment, E, all right? And we're going to label that effect so that it has the same direction as the force on the positively charged object. So we charge it up positively, with the triboelectric effect, for example, and then we'll see exactly what happens to it afterwards, right? So that's what we're looking at. Some other things is that if you have a force, or if you have this object with only 3 charges instead of the 4, the force up here will be 3/4 of that original force, right? So this force also changes with the amount of charge, right? We don't really have a good way of measuring charges right now. We will later, but right now we don't have a good way of doing it. But if we had a good way of measuring it, we find that something with 1/3 the number of charges on it, or 3/4 of the number of charges on it, will feel 3/4 of the force. So that's what we're going to be looking at here. Now this thing E is what we call the electric field, so that everywhere in the universe, everywhere in space, there is this electric field. All right. So what we want to say about that electric field, and this is basically how it's defined, is that when a charged object is placed in it, it feels a force, proportional to its charge. That's the definition of the electric field. It's the thing that does this. so what that's going to mean to you when we have to do problems and stuff like that is that the force on the object is equal to the charge on the object times the electric field. Okay? If you need to find the electric field, then it's just, divide by Q. You feel the force and divide by Q. That's it. So the field is not itself a force, but it creates a force. Now we're at A. Also, the direction of the force is going to be along these field lines, right? So the direction of the force is the direction of the field, and vice versa. Oops, forgot an entire word. And what that's going to do is that's going to let us use all that stuff we used in Physics 1, all that stuff we did in Physics 1 that you loved so much. We're going to be able to use all of that stuff with electricity and magnetism, or electricity at this point. We'll have a different way of incorporating magnetism later. But, everything is going to show up just through this equation, and we'll be able to use that to balance forces. That's what we'll do in the example. Or to find accelerations, which we also might do at some point. But, that's basically what's going to happen with the electric field. That's the basic idea behind it, is the electric field is the thing that generates the force on a charged object, all right? And that pervades space. Everywhere there's a value for the electric field, although that value could be zero. It's generally not, but it's generally small. So you'll always be able to get something there. Now, electric forces and electric responses are really important. Basically, everything that you know about has something to do with electric fields and forces. But this is the basics behind all of that right there. All right? So, thanks for listening. I'll talk to you later. Bye now.